Welcome back to Everyday Nuggets. Have you ever snapped a rubber band and wondered how something so simple yet versatile came into existence? Rubber bands are essential tools in our daily lives, found in offices, homes, and countless industrial applications. These stretchy loops might seem unremarkable, but their creation involves a fascinating blend of natural resources, chemistry, and engineering precision. The journey of a rubber band begins in the tropical regions of our planet. Natural rubber comes from the milky white sap called latex that flows within the Hevea brasiliensis tree, commonly known as the rubber tree. These trees, native to the Amazon rainforest, are now primarily cultivated in Southeast Asian countries like Thailand, Indonesia, and Malaysia, which produce over 90% of the world's natural rubber. Harvesting latex is a delicate process that has remained largely unchanged for generations. Skilled workers make diagonal cuts in the tree's bark, creating a channel that allows the latex to flow down into collection cups. This technique, called tapping, is carefully executed to avoid damaging the tree. A single rubber tree can produce latex for up to 28 years, yielding approximately 9 pounds of rubber annually. The collected latex is a complex emulsion containing about 35% rubber, 60% water, and the remaining as small amounts of proteins, fatty acids, and minerals. This natural composition gives rubber its remarkable properties, but the raw latex must undergo extensive processing before it can become the stretchy bands we recognize. Once harvested, the latex begins its transformation. The first critical step is preventing the latex from coagulating prematurely. Workers add ammonia as a preservative to maintain the liquid state during transportation to processing facilities. At the processing plant, the latex undergoes filtration to remove impurities like bark fragments, insects, and dirt. The cleaned latex is then ready for the crucial process of coagulation. Manufacturers add formic or acetic acid to the latex, which neutralizes the electrical charges that keep rubber particles suspended in water, causing them to clump together. This coagulated rubber is pressed between rollers to remove excess water and form sheets typically about 1/4 inch thick. These sheets are then hung in drying rooms or smokehouses, where they're dried for several days at temperatures between 100 and 140 degrees Fahrenheit. Smoking the rubber not only dries it, but also introduces compounds that help preserve the material. The dried rubber sheets, now a pale amber color, are packed and shipped to rubber band manufacturing facilities around the world. At this stage, the material is still raw rubber and lacks the elasticity and durability needed for commercial rubber bands. Manufacturing rubber bands requires a precise formula of additives mixed with the natural rubber. This process, called compounding, is where science and craftsmanship meet to create the perfect rubber band. The primary ingredient remains natural rubber, which typically constitutes 50 to 70% of the final product. To this base, manufacturers add various chemicals that enhance performance. 1. Vulcanizing agents, primarily sulfur. These create crosslinks between rubber molecules, giving rubber bands their elasticity and preventing them from breaking when stretched. 2. Accelerators. These speed up the vulcanization process, reducing production time. 3. Antioxidants. These prevent the rubber from degrading due to oxygen exposure, extending the product's shelf life. 4. Pigments. These provide color to the rubber bands, from the standard tan to vibrant colors for specialized uses. 5. Fillers. Materials like clay or calcium carbonate can be added to modify properties or reduce costs. The precise formula varies between manufacturers and depends on the intended use of the rubber bands. This proprietary blend of ingredients determines the band's stretchiness, durability, and resistance to temperature changes. After the cutting and vulcanization stages, The rubber bands enter a crucial phase of quality control. Every batch of rubber bands undergoes rigorous testing to ensure they meet specific standards for durability, elasticity, and overall quality. First, samples from each production batch are stretched repeatedly to test their elastic limit. This process simulates real-world usage conditions, where rubber bands might be stretched hundreds or thousands of times throughout their lifespan. Bands that snap too easily or lose elasticity quickly fail this test, and the entire batch may be rejected. Color consistency is also carefully examined. For colored rubber bands, manufacturers want to ensure the dye has been evenly distributed throughout the rubber mixture. Uneven coloring could indicate problems with the mixing process that might affect the structural integrity of the bands. Thickness measurement is another critical inspection point. Using precision gauges, quality control technicians verify that each rubber band maintains the proper thickness throughout its circumference. Variations in thickness can lead to weak points that might break under tension. Did you know that many manufacturers also perform chemical analysis on sample bands? This ensures the rubber compound has the right balance of ingredients and that no harmful chemicals are present in the final product. Once rubber bands have passed all quality control tests, they move to the packaging department. This is where the journey from factory to consumer begins. The packaging process varies depending on the intended market and product line. For bulk industrial use, rubber bands might be weighed and packed into large boxes or bags. Retail consumers typically sort products by size and color before packaging them in smaller quantities. Many rubber bands are packaged by weight rather than count. A standard 1-pound box of assorted rubber bands might contain anywhere from 150 to 3,750 bands per pound, depending on rubber band size. Modern packaging lines use automated counting and weighing systems that can process thousands of rubber bands per minute. These machines sort the bands by size, weight, or color before directing them to the appropriate packaging station. Some specialty rubber bands receive additional treatment during packaging. For example, rubber bands intended for medical or food handling applications may undergo sterilization procedures before being sealed in sterile packaging. The rubber band industry, like many manufacturing sectors, faces increasing pressure to address environmental concerns. The production of rubber bands involves several environmental considerations that modern manufacturers are working to address. Traditional rubber harvesting has been linked to deforestation in some regions. To counter this, many companies now source natural rubber from sustainable plantations that follow responsible land management practices. Synthetic rubber production relies on petrochemicals, which raises concerns about carbon footprint and fossil fuel dependency. Some manufacturers are exploring bio-based alternatives that can reduce environmental impact while maintaining product performance. The vulcanization process historically used chemicals that could be harmful to the environment. Today's manufacturers employ cleaner technologies and closed-loop systems that capture and neutralize potentially dangerous byproducts. Natural rubber bands biodegrade in 10 to 20 years when exposed to oxygen and ultraviolet light. That's why proper disposal and recycling are encouraged whenever possible. From plantation to packaging, the journey of a rubber band involves numerous precise processes and quality checks. These simple yet ingenious products demonstrate how basic materials can be transformed into versatile tools that serve countless purposes in our daily lives. The humble rubber band represents a perfect balance of simplicity and functionality. Despite being one of the most basic office supplies, the manufacturing process showcases impressive engineering and chemical precision. Next time you stretch a rubber band around a bundle of papers or shoot one across the room, though we don't officially recommend that, take a moment to appreciate the complex journey it took to reach your fingertips. Thank you for watching Everyday Nuggets and this exploration of rubber band manufacturing. If you found this interesting, please like and subscribe for more videos that reveal the fascinating processes behind everyday objects. Stay tuned for our next deep dive into the things we often take for granted.